How to build the best amplifier in the world, or how to build an amplifier at such quality that you cannot get better results with meaningful investments. When I did high quality audio forum research, I found out that majority of Class D amplifier addressed topics reduced it to 3 manufacturers: Hypex, Purify and ICEpower. A general trend is to position Hypex over other brands, making it number 1, using a broad range of arguments. For a long time, I have been looking for someone owning all 3 brands' top designs for at least 12 months. It is a specific case, and I have found only 2 cases. What they are telling in the forums: during the regular device rotation and listening to music over and over, they were not able to tell a tangible difference between Hypex, Purify and ICEpower top models at reasonable listening volume. My personal opinion matches this statement. All manufacturers achieve this human hearing threshold, and the moment when quality is a standard feature. Other factors like price and functionality are taking over the tiny bits of specification difference. To compare different manufactured products, we need to set a basic criteria. There is my list. From all manufacturers' lineup, I took ICEpower latest design 1200AS2. Why this model? For some time it is available in the retail market, and anyone who wants to build the best amplifier in the world can get access to it. You are right, I'm building an amplifier kit for those looking for the best amplifier in the world. So, let us set the criteria for the best amplifier in the world. There is my list. You can see 4 columns. First indicates criteria. Second is criteria short description. Third, importance of criteria. And fourth is my score for the unit. When we compare more units, I would add one more column with a weighted score where multiplies the importance value with a score. Those who have access to all boards can do that and bring interesting scoring results to public. Let's take a closer look to criteria. Audio quality is a main criteria for everyone building the best amplifier in the world. Importance 10, and since I do have hands-on on ICEpower 1200AS2 boards, as well as long-time listening tests, I'm scoring it at 10 points from 10. In my opinion, everything is a perfect, including such a stress tests as a dominant voice and background instruments. If you have even a smaller limitation in amplifier design, the dominant voice vocal at certain volume starts shadowing music instruments, or in simple words, we are losing details. Only a perfect amplifier can withstand such a test. Universal mains. Plug-and-play capability to work in countries with 110 volts, like US, Japan, and 220 volts, Europe. Importance 8. And as long as it is in a board standard functionality, scoring for 10 points. Reliability. I want my design lasting for 20 years. A robotic assembled single board has highest reliability specifications when manufactured from the good components. ICEpower 1200AS2 has a single board design. There may be argument that the modular design may have more flexibility to repair parts of our design. In modern design there are 2 scenarios. Board is working for a long time or has an issue and we scrap it. Good designs are working for a long time. Look to computer industry's complexity or video camera. Those are far more complex designs and defects are more exceptions than pattern. Single board means better design, scoring for 10. Wake up from signal. The best place for power amplifier is close to speakers. Remote wake up from signal may be a valuable feature when center of your audio system is more than music streamer. But it is nice to have function with low importance, scoring important 3. It is built by design in this board and scoring for 10. 12 volts trigger, popular solution how to remotely switch on and off power amplifier. Importance 5, Score 10. Function is implemented by design. Standby consumption. Important for worldwide sales. Board has an Energy Star 250 mW consumption in standby mode. Importance 8 and score 10. Input second quality is critically important for audio quality. 1200AS2 has state-of-the-art balanced high impedance input circuits. Importance score as 5. Because you can always implement your designed input circuits. It is implemented in the board, scoring 10. Telemetry. Remote monitoring of amplifier components' health. Not important for do-it-yourself designs. Importance 3. This board has great telemetry set, scoring at 10 points. It is important for professional designs with high reliability requirements. You can integrate microcontroller, collect telemetry data and transmit over internet to central management system. How much power do I need? This is one of the often discussed forum topics. To make our final choice, we should have clear understanding of this topic. One of the trade-offs that you should make is power. More good power means more investments. When looking to the best amplifier in the world, you should decide how powerful system you want to build and where is the sweet point where you are capable to listen any type of music in reference quality. For optimum price, let us look to the Harbert's Lab experiment. In this video I have included the key moments from Harbert's Lab story. Those are engineers designing a reference monitor for BBC recording studios with lifetime experience and expertise in audio field.
The issue comes up occasionally on the user group about amplifier power. How much amplifier power do I need to get the best out of my Harbets? So when I write the specification for how much power I think is going to get the best out of our speakers, I have to balance the reality of how much money the consumer is willing to invest in his amplification, how much space he's got, how close he is to the loudspeakers, and what type of music he wants to listen to. So the amplifiers we have here today have a power meter reading on the front. And if we take a look at that when we play some sort of exciting, dynamic electronic music, I think we're going to get a shock.
Hi there, I'm Garm van der Zel. I belong to the company Audio Ingang, which imports the Harbet speakers here in the Netherlands. And we are at Beter Beeld en Geluid, and we want to do a demonstration of a piece of electronic music from Pensonic. And it's pretty dynamic, so it will show you how much power we really need for these kinds of tracks.
What have we got here?
So what we have here is two amplifiers in bridged mode.
Wow.
Which would deliver 350 watts per channel continuously, but it can deliver up to maybe 1,000 watts or more on peaks.
Wow.
Music.
And these meters, are they telling us about peak power or average power, or how do they work?
They measure at certain intervals, and they will give you instantaneous reading of the maximum power that is given at any moment.
So these two amplifiers, left and right, have a potential power output of up to 1,000 watts instantaneous.
Yes.
Probably 500 watts continuous, something like that.
Mm-hmm.
If I said to you that we regularly read of consumers who passionately believe that their 7-watt amplifiers can give them a full dynamic sound, what would you say?
I would think when you, in certain conditions, with certain non-demanding music, it could be okay, but most of the time you're listening to a distorted amplifier.
Right, well, roll the music.
Right, okay. Alan, what's that told you about the power handling?
Well, what was the largest wattage demand that you saw?
I think we safely saw 750 watts going into the speakers. So that's quite amazing when you think of it.
Were you surprised by that?
Yes, I was definitely surprised, and because it was continuously so much power, and yeah.
I mean, it was regularly over 500 watts.
Yes,
it?
yes.
Yeah.
Yeah.
Trevor, without my glasses, I can't read it.
For the 40.1, we say power handling 200 watts program, suggested power from a minimum of 50 watts per channel.
I mean, 50 watts, it's the absolute minimum.
It's the bare minimum. I think it's depending on the program material. If you're listening to like string quartets and you're up close
And
and
BBC control room, for example.
right.
largest
You
monitoring-
don't need
No.
those amounts of power. But if you want to have a great selection of music and you want to listen at realistic volume levels, then I think you're going to need more power than 50 watts. What we've shown. Yeah.
Do you have another example on your machine there of just how little power you might need for, say, a classical quartet? Well, I think that proves the point. The maximum peak power that I saw was about 28 watts. We were playing louder than we perhaps normally would play Corelli at. So I think our recommended minima is about right for that kind of
Yes.
lightweight music. But as we've demonstrated, more dynamic music is going to need vastly more power, and that's the point. If you can match your amplifier to the type of listening that you do, to the type of loudspeaker efficiency, to the type of listening distance you are away from the speakers, there's no doubt that a small amplifier could and should provide a satisfactory performance with a minimum of, say, 30-40 watts, something of that order. But as soon as you move out of that comfort zone, you're going to need a lot more power, or the music is going to be compressed. It's that simple, I'm afraid.
Why ICEpower1200AS2 is so good? There are so many world-best amplifiers presented in forums, websites and leaflets. I would like to drill down in this particular design details. There are several design components in this amplifier that are ahead of the market and differ from the rest of the crowd. ICEpower technology. Today most of the Class D complexity are hidden in the gate drive circuits. To make your design simple with repeatable manufacturing process, you need the best possible gate driver. ICEpower Edge technology consists of the latest generation gate driver or controller and driver chipset for high power amplifier solutions, where you need a buffer stage between controller and high power MOSFETs. Those two chipsets solving the main issue with the Class D audio quality. We are going beyond the human hearing threshold. Amplifier stage is done, and competition is moving to power supply design and quality. Small place for competition will stay in power MOSFET choices, but majority of good Class D designs are using the same component suppliers. Having those chipsets, ICEpower has significant advantage among OEM Class D board manufacturers due to the out-of-the-box quality and low cost by design. My guess is that in the next release we will see more and more designs based on ICEpower technology. I'm waiting for a single board integrated power supply and 3-channel amplifier solution, where one channel would be bridged architecture with output power of about 500 watts and two channels about 100-150 watts on four-ohm load. That will be perfect three-way speaker driver solution with active crossover architecture. For high power solutions starting from 500 watts you need a phase corrector and power supply input for effective mains utilization. Without PFC circuits you cannot certify your designs and be successful on board manufacturer. This is typical PFC circuit with bridge rectifier in board input. For electromagnetic compatibility you may have filter before the bridge as well. Standard architecture: power bridge, large inductor, high power MOSFET, voltage multiplier, and filter capacitor. An alternative design is so-called bridgeless architecture, where we don't have a rectifier bridge before fuzz corrector circuits. Here is one slide from Texas Instruments training course about PFC circuits and switching mode power supply design. There are three possible solutions, each with its advantages and disadvantages. The general disadvantage is complexity. I guess 1200AS2 has so-called AC switch version. But it is just a guessing because I don't have the schematics of this board. Let's take a closer look at the board components and design elements. How does it look in practice? I think that this board is using following fuzz corrector circuits. That is simplified version, just to understand the basic principles and find similarities in amplifier board. Hard to say, does practical implementation using two inductors or just one, but two inductor version would have better electromagnetic filtering characteristics. So what we have? Connectors to the main, onboard fuses, some filter capacitors, PFC inductor, it is covered with protection cover. Large MOSFETs are connected to the opposite side of the board and attached to the heatsink. We are looking at least to 2 kW capable power supply components. Then we have an inrush current limiter, additional filter, inductor. It is located somewhere here before a bridge. Then we have a bridge, and small electrolytic capacitors and very large film capacitor. The biggest advantage of this complex design is the lack of the large high voltage and capacity electrolytic capacitors in the primary side. Bingo! The first huge advantage to reduce costs and raise the reliability of the complete system. You can see on the secondary side we have a large ordinary electrolytic capacitors rated for 80 volts and 4700 microfarads. Ordinary capacitors, but those are the good ones with rated internal impedance. The low impedance capacitors are twice as large as the ordinary capacitors. But anyway, those are mainstream capacitors produced in large factories. Everyone is using them in standard amplifier circuits. We can use legacy on Class AB amplifier industry. Then we have a small transformer. It's standby transformer who provides those small 250 milliwatt power for a wake-up calls for this amplifier. Quadro Balanced Design. This concept is patented by Macintosh. That means they have 4 high-quality amplifiers precisely bridged to build a one stereo amplifier. There are following advantages. You can reduce significantly the noise of such a system. What is disadvantage? You need twice as many components than for normal single-ended amplifier. To fully benefit for such architecture, you need really precisely bridged amplifier circuits. That means you need a single chipset drivers, you need a single chipset input circuits. But once you implement those requirements, you will achieve very low noise floor. How about ICEpower? We have a single chipset controller with 4-channel outputs, precise single chipset MOSFET drivers, high quality balanced input circuits. ICEpower1200AS2 has Quadro Balanced architecture by design. Each stereo channel has been bridged with a high tolerance component match. There are several additional advantages. 1.2 kW capable power amplifier rail voltage is low, just plus minus 65 volts. You can use cost-effective electrolytic capacitors produced in the volumes by broad range of manufacturers. Capacitors are on the secondary side of the power supply, close to the output transistors. The high current path is short and there is no main transformer in between. The design has very good instant power capability. The bridged solution is faster than single-ended when you need to transform power to the speakers. I did a similar design using ICEpower1200AS2 too, when precisely bridged by the well-balanced preamplifier. They produced audio details what single-ended is not capable of. And of course, power capability rises to 500 watts. I do have several surprised customer emails who assembled my VH500 amplifier kit just for fun. Now, some advantages of such architecture. Yes, this amplifier has very low noise, even in specs and in reality. Cancellation of even ordered distortion products. But you should have really precisely balanced architecture. Reduce voltage induced distortions in the gain stage. Increase output voltage swing may improve bus control. We can get high power with a low rail voltage. And one more thing, eliminates bus pumping effect of Class D amplifiers. Class D amplifier is a switching amplifier, and those switches working as a voltage multipliers. When you have a low frequency, high current music, like boom, 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 they start to multiply this voltage back to the power supply. In bridged connection, you don't have this artifact. There's special protection built in amplifiers to avoid such kind of disaster. But when you bridge it, you can run any kind of bus. Everything is clean and fine. Designer manual notes. Things to know before building your dream amplifier. By default, I am expecting that everyone read designer notes of ICEpower1200AS2 board. But let's be real. It not happens. So, in this chapter we will go through most important designer notes. ICEpower1200AS series has two modifications. Single channel version and stereo version. Here you can see the difference. The one channel components has not been soldered. Another board is completed. As they are sharing the same main board, the key difference is just lack of those components. Is it worth to buy two versions of the boards? In reality, I think no, because with the stereo version you can do the same. In a one-channel version, we can add a hanger module here, making three-way active speaker system. You can attach 400 watt stereo board based on the same technology and build a powerful three-way system for live performance. You will have 1 kilowatt for a woofer and 400 watts for a mids and tweeter. ICEpower1200AS2 are two fully integrated audio power amplifier modules, including universal mains, ERP and Energy Star compliant power supply. What else is worth mentioned? Comprehensive protection and monitoring functions. Easy to use control interface. Dedicated monitor outputs for speaker control output voltage and current for most demanding systems where you should be 100% live all the time. Integrated aluminum base plate for a cooling and mechanical interface. Enables easy mechanical integration and extra cooling can be added. For me, this is the most important. It's safety pre-approved and you can sell in any market with a minimum time and effort and money. Certification is expensive. Features. What manufacturer is saying about this board? It's fully integrated 1 or 2 channel amplifier, we know. No need for additional circuits for simple application. That's important. Short circuit overcurrent protection, yes. Real-time voltage and current output monitors, yes. Comprehensive monitoring and protection, yes. Clip monitor per channel and thermal warning outputs. That's important because you get a warning before board is shutting down. This is important. Board has built-in audio signal trigger and logical trigger, so you can turn on with either with a signal from your preamplifier or use a 12 volts to turn on amplifier. Good if your amplifier closer to speakers and your control center is remote. Auxiliary power supply output, powerful auxiliary power supply output, about 38 watts. Standby mode with low power consumption, just 250 milliwatts. Energy Star version 3.0 compliant. I like those marketing titles. Universal mains, we already talked about that. MC and safety approved. Simple flexible mounting. ICEpower standard connector and pin definition. I'm not agree. I needed a couple of new connectors and sourcing was not that easy. Prepare for hunger amplifier module. Yes, you can build a three-way systems. Short about specifications. 1.2 kilowatts at 4 ohms per channel, running one channel. Very nice total harmonic distortions. 50 kilohertz audio bandwidth. But pay attention to this figure. It is about a noise. Really, output noise, if you do everything properly, is really, really low. Even from 10 centimeters, it's difficult to hear that your speakers are turned on. Minimum load impedance 2.7 ohms, but you can work with the 2 ohms as well, just with reduced power output. It's current limited. Maximum output voltage. It is more about the power supply DC capability. Auxiliary voltage 5 volts and plus minus 15 volts, but you need additional stabilization and cleanup of the signal. Universal mains, yes, for all countries, from 100 to 240, in reality even more. And size 300 millimeters, 100 millimeters and 63 millimeters. Those who are living in inches, there are inches as well. And safety confirmation certificates. Excellent. Here is general board layout. What do we have? Here is the input connector, hunger module connectors. Here is a main voltage plus minus 65 volts, and here is a service circuits plus minus 15, and maybe something else. Here we have a telemetry and controls. One channel output, second channel output, signal input, and voltage and current sense. A legend of the mains connector. You can see that ground is not connected to the board. Basic control connectors. This is DVDD. It's 5 volt auxiliary power supply. And there is another one for a standby. It is always on, and you can attach circuits for a wake up. Analog power supply 15 volts positive, negative analog voltage supply, standby input. You should provide high signal to enable it. Okay, clipping, protect. Module protect indicator, status output open collector and active low. When it triggers, then it goes low and your light diode is working. And you can see that this ground or ground aux, it's not directly connected to the chassis. We will look at that later on. Advanced controls. This is a large connector, 22 pin connector. At moment of this video, I'm waiting for shipment of this connector. I don't have them to show it. From this connector, we are interested only on the lower part. This is remote control of the amplifier, and here is the trigger and signal sense connector. We put it in parallel to one of the stereo signal inputs. A loudspeaker connector. I want to draw your attention that 2 pins of connector are set in parallel. Connector has 4 pins and pairs are parallel, like 1 and 2 is in parallel and 3 and 4 is in parallel as well, to ensure that those pins are capable to withstand high output current. Stereo signal input connector, and it is fully balanced. You need a shield, plus and minus, and the second the same, shield, plus and minus. Could you connect it in unbalanced way? Yes, but you need a very high swing. And the second output connector is the same as the first one. And second output connector, the same connection pattern as the first one. Power supply capability. Here we are talking about a DC power supply maximum capability or instant current, what is very important for a good bus reproduction. And you can see it's rated by 100 volts peak and 38 amps. How much peak power we can get? 3.8 kilowatts we can instantly provide. It's very important. It's very good at the low frequency reproduction, and we have a lot of headroom for a great performance. Calculated rated output power is 1249 watts, but we don't have a 100% efficiency, so it relates what manufacturers told us. How about current at 4 ohms at full load? Average it's 17 amps, but the peaks are 24 amps. Do you remember that there was parallel pins on speaker output connector? Continuous speaker connector 1-pin output current is rated to 7 amps. Average could be much higher, but anyway, it is recommended to set those pins in parallel when you're operating at full power. Mechanical specifications. Important to evaluate final unit weight and dimensions. Stereo module weight is 1.2 kilograms, 1.3 kilograms. Could you imagine it is kilowatt amp at such a low weight? Base plate thickness, I would say it's 3 millimeters. Mounting hole depth, that's important. It's a 3 millimeter threads, and you can use 5 millimeter screws. And be reasonable when applying force and securing them. 0.5 Newton meters are rated. Mounting holes, you can secure them in a 2 different ways, either using those side holes and secure to larger heatsink, or use a chassis for securing the board, and then you have 18 holes together to secure board to the chassis. Look at dimensions. You will be pretty precise. Environmental specifications. With active cooling you can work up to 60 degrees Celsius, really in tropical countries. With passive cooling, ambient temperature shouldn't exceed 40 degrees. For storage, from -40 to +70. It could be important when you are traveling with a mobile setup in north of Norway, and then probably there's a low temperatures in a cargo space. One more important specs, it's about random vibrations and shock. Board meant to be for mobile applications as well, and engineers tested and monitored. It's certified for mobile applications, and you can see forces what you can apply. Frequency response, extremely flat. It's unbelievably flat. But here on a 20 kilohertz we have 0.5 dB drop. And in the forums you can find out that flatness is not perfect. But what does it mean, 0.5 decibels on 20 kilohertz? Theoretical human hearing resolution is 0.25 decibels. On the most sensitive region, somewhere here. On the low frequencies and high frequencies, our hearing resolution is significantly less. With difficulties we can hear 3 decibels at 20 kilohertz. Second, not everyone is hearing 20 kilohertz. Let's take a look of symphonic music instruments and harmonics, what they can produce. At the lower end, symphonic music instruments are going down to 47 hertz. No, to 41 hertz. That means if you have speakers rated for 35 hertz, you're completely covering everything what modern music can do. And how about the upper harmonics? Somewhere about 16 kilohertz. That means music instruments are not playing very high. And at the 20 kilohertz there's practically no music anymore. When I was young, I tested my hearing, and at the age of 27, I was capable to hear 18.7 kilohertz. But never in my life I was able to hear 20 kilohertz. You should be really gifted to hear 20 kilohertz. That means if we can make some small compromises, then at 20 kilohertz we can do that. Total harmonics and noise. This is the biggest battlefield in audiophile community. And I will find out that there are people who are measuring amplifiers and rating them according to the total harmonic distortions. But it's not a key parameter to compare amplifiers. For example, here is a 0.1% of total harmonic distortion. Scientifically, it's proven that this is a human hearing limit. And if you look at the speakers or loudspeakers, then they are rated about 1%. And the best of the best loudspeakers are capable go down to 0.1% of total harmonic distortion. There was a time when manufacturers just indicated that their amplifier total harmonic distortions are below 0.1%. But something happens in a community and those total harmonic distortion parameters become marketing parameters. So everyone starts to fight for a smaller total harmonic distortion. From engineering point of view, you can achieve very low total harmonic distortions slowing down amplifier with a deep negative feedback. And this amplifier will sound like a crap, but you will have very good total harmonic distortions. Be careful when you're really judging amplifiers just for this one parameter. Of course, another story is that with today's electronic components, you can build amazingly good amplifiers with low total harmonic distortion. For today's equipment, when electronic components are so good and your final design has high total harmonic distortion, that means it's just a bad design. But should be careful with total harmonic distortion judgment. It's a marketing. Where we are today, we are even more than 10 times better than human hearing threshold. What if we go there? There are some amplifiers today going even there. No, I should say it's a lab test. When you put complete system, then we're coming back somewhere here again. This is a real fight area. And what happens? We're going lower and lower at total harmonic distortion. We are rating amplifiers and putting them even in a row, which one is better, which one isn't. No, we should be rational. Below 0.01%, those are exceptionally good amplifiers, exceptionally good systems, and there is no reason to really fight on these crazy numbers there. It's useless. Damping factor. Another marketing element. Often in the forums you can find out that ICEpower has only 750 damping factor, but Hypex has 820. Hypex is much better in a master production. But when we're talking about the parameters, we should understand the physics behind. What is the meaning of the damping factor of power amplifier? It's output impedance rated to load. No, in our case, 4 ohm load. Those 700 numbers are crazy high. Let's take experiment and make damping factor infinite. So we take a speaker and shorten the inputs. What will happen? There's some resistance when we try to move speaker. Actually, this is a maximum force or a maximum control what amplifier can apply to woofer. That means there is a finite force. Even having infinite damping factor, we are not able to fully control speaker. And what is the reasonable numbers of damping factor what really impact our sound? Guess. It's between 50 and 100. Then 50 is good, 100 is marginally excellent, and below 50 we can talk that damping factor maybe is better or not better. You still don't believe me? Let's take one example. This is really top line amplifier from Macintosh. It's not for free. And where is damping factor? Yes, damping factor is here. It's 40. And nobody is telling this amplifier is bad. He can control any kind of speakers. I listen to them in saloons, fantastic device, really impressive. And damping factor is just a 40. So be reasonable with specifications and bold statements when we are using one or another specs number. Physics behind is more important. When we are talking about the damping factor impact to sound, we should look on a complete system. And here you can see typical three-way crossover. There is always large inductivity in series with a woofer. Here we have. Even this is a good one. And if you look at the wire, it's about 1 millimeter wire, what we have here. And it's long, I would assume about 15, 20 meters, or maybe even more. So all this resistance is in series with a woofer. Again, importance of damping factor. We're losing a lot of damping factor here. Ohmic resistance here. Probably this is one of the reasons why we should go for active system and put amplifier connection here. And then higher damping factors has sense. And let's take advanced system with 24 decibel passive crossover. What do we see on the woofer side? We have 3 inductivities. Those are probably here. Who knows? Large inductivities, the same. A lot of wire has been winded here. Here is ohmic resistance around it. Those reducing damping factor or our possibilities to control a woofer. I would say that damping factor absolutely is not a critical element, and it comes more as a design side effect. Because when you're using high power switching MOSFETs, they have very low open resistance, and damping factor definitely is super high. It's higher than in AB class architecture. It's just a side effect. Output power per channel versus mains voltage. You can see that this is not linear for any for different input voltage. That means in the States we are losing about 50 watts on the total output power, but not much. In Europe we have everything fine. When assembling amplifier, we should follow the guidances given by manufacturer. And here is how properly ground and connect input circuits. If you do everything by the book, you will have a dead silence on an amplifier output. It will be absolutely perfect from the noise perspective. But if you make some mistakes, then shit will happen. When you have a balanced connection, look how it should be connected. The ground is connected on the source side. On a board, you connect it to that indicated ground, not to chassis, not to other part. Here, this is only point where you should connect it. And it is grounded to 22 ohms resistor. You can see it's not directly connected to the board ground. That's important. What else can we see of this board? It has a high impedance buffer, and as a result you have high impedance input, about 47 kilo ohms. ICEpower1200AS series has very good input buffer. You don't need to build another one or try to improve it. It has built-in excellent input buffer for balanced circuits with high common mode rejection factors. Semi-balanced audio input interface schematics, or unbalanced. I want to draw your attention to those 2 resistors, R10 and R11. R10 is a source output impedance. Typically it's about 100 to 150 ohms. For the proven manufactured devices it's a given number. And when you connect to the balanced input, you should artificially add one more resistor in a series between the ground and minus. Then you get a high common mode rejection values. What would happen if you not add this resistor? Nothing. For a short distances it doesn't make sense. But if you have a longer cable, then it makes sense. Control inputs. There are a number of control inputs including 12-volt trigger. Important part is here. You can see that this is a high value resistor, 33 kilo ohms, and eliminates current through the transistor. Even if you put 12 volts here, nothing bad will happen. Manufacturer recommends 10 kilo ohm series resistor to the driver signal for that input. But as I mentioned, nothing bad will happen if you put 12 volts directly here. Status output interface schematics. Pay attention that here low value resistors. For example, if you put here 5 volts, those two resistors limit current to 20 milliamps. And it will be secure for this transistor. But if you go with the higher voltages, then you can burn it. Manufacturer recommendations is put series resistor with your light diode and eliminate current to 10 milliamps. It depends on what light diode you are using. Grounding schema. Extremely important slide. Wake up and listen. This is a place where you can make fatal mistakes. And let's take a closer look how it is made. This sign means chassis. And you can see that this is comprehensive grounding schema. Practically there is no paths directly connected to the chassis. Always there is kind of low value resistors everywhere. And even between different points of chassis connection, there is additional schema. Actually, a lot of white papers has been made about this topic, and those are critically important, and not every engineer knows the basics of that. What kind of mistake you can make? There is one. When you touch a 12-volt trigger connector, it is connected to the chassis, and ground pin is connected to chassis as well. For example, and if you this ground pin from the chassis to the common ground, you are shortening that resistor, and all your grounding schema is down. When connecting 12-volt trigger, only hot wires should be connected to the trigger input. What happens when you do that? The system will operate, but you have unpredictable behavior of where you connect, what cables you use. All the time there will be slight difference of noise in your speakers, and you will not understand what happens, why it's not so deadly low as promised. Don't do such things. 1200AS2 board has almost infinite channel separation. It's not an issue. It's below human hearing threshold. Both channels are working as a fully separated. It's not an argument to have two monoblocks. The key argument to have two monoblocks is the power. When you need 1 kilowatt per channel, yes, then you use two monoblocks. Input sensitivity. You can see it's a 5-volt peak. And here we should understand peaks and RMS. Let's calculate to RMS. It's 3.5 volts. So to have a full swing of your amplifier, you need 3.5 volts RMS signal. Good professional audio interface provide it. Here's a Zoom USC2. It's actually very good audio interface, and you can use it as a high quality digital analog converter. And maximum output level, here's the 14 dBu. Again, we are falling in a terminology and different type of measurements. You need a theory behind. But let's just put in a calculator 14 dBu and we get out 3.8 volts RMS. With this interface, I can drive my amplifier at a full power. Perfect. Electromagnetic compatibility management. Let's simply don't do stupid things. The first picture is scenario when you have from amplifier to speaker two fully separated wires, and it's a worst case scenario. You shouldn't do that. It's bad. Better scenario when those wires are close in parallel, and this is typically what you have. When you buy a speaker cable, they are flat and two parallel wires going from speakers to from amplifier to speakers. Much better scenario is when you twist two wires. You can take even a simple 1.5 or 2 millimeter flexible cables and with a drill twist them together. It will be fantastic wire, it will be fantastic speaker cable. It will be flexible, it will be good from EMC management perspective, and it will be cost effective. And the last scenario, when you have dedicated, shielded, super trooper speaker cable, minimum 10 to 15 euros per meter, then you achieve the same as in scenario above, but for much higher price. I would say that the best scenario is twisted wires. You will be amazingly happy with it. Try. You need a drill machine, two wires with a 1.5 millimeter section, twist them together, and it will be fantastically sounding cables. No, let's don't do stupid things like putting inputs together with outputs. I hope everyone knew that. It's a crazy thing, and you can go in a loop. It's very bad. Try to separate them. And it's the same about the controls. Controls also should be separated from the mains output. This is absolute basics what you should know, but I really recommend to read designer manual carefully. Practically all things, all details what you should know when assembling either kit or building your own amplifier are specified here. If you have a minimum electronic knowledge, it is easy to understand. I try to explain all possible tiny details or things where you can make mistake, especially about the grounding. Be careful about the grounding. It's important. Once you make a mistake, it's very hard to find it, and you will be really surprised at what's happening. Assembling instructions or amplifier assembling video guide. In about 30 minutes we will complete amplifier assembling. First we need an enclosure for our dream amplifier. I was not happy with ready-made option and decided to design a dedicated enclosure. This board is too good to live in an adapted enclosure, typically struggling from the overheating and not optimal board placement. Most of the competitor designs were not meant to run ICEpower1200AS2 at its full potential. The enclosure will be made from a 1 mm aluminum sheet and folded, keeping unified structure for better heat dispatch. Once you are spending significant resources on your project, it is worth considering design enabling all amplifier functions and capability to use for a professional scenarios as well. A professional scenarios means running at clipping level for infinite time without overheating. You are right, the solution needs active cooling. To be applicable for both markets, high-quality music lovers and professional applications, high-quality fan with PWM is the best choice. We were so passionate about this project that we designed an alternative enclosure for the professional market. When designing products, we should think about the strengths and weaknesses of your company, looking at how to differentiate yourself from competitors. Creativity and pragmatism should go hands in hands. Minimum footprint module design is our answer to the market. There are the following benefits of this design. Standardization. You can have exchangeable small footprint lightweight units. You can use them in different combinations, like running two-way system with an active crossover, 4 ohms woofer and 8 ohms passive tops, just using one ICEpower1200AS2 board. Woofer about 1 kilowatt, tops for about 200 watts. It is already a killer system. Once you can use 2 amp units for woofers and 1 unit in stereo having 2 kilowatts for low frequencies, 600 watts for mids and tweeter per channel. With high efficiency speakers, we are close to live outdoor concert requirements. You can raise system reliability by having N+1 configuration once units are standardized. There is an advantage of split structure. You can place amplifiers close to speakers, reducing connection cable lengths, still keeping the overall system flexibility. Those are just ideas, but the concept has some potential. I will build a working prototype. Now we are ready to assemble the device. Let's take a closer look how our board looks like. Dimension: length 300 mm, width 100 mm, the same as in manual. How about the weight? It's 1258 grams. Let's round to 1.3 kilogram. And it is 1.2 kilowatt amplifier. Let's look to the board building blocks. A main voltage input, on-board fuses, PFC circuits with a large inductor. Look at the details. You can see how complex is the phase corrector. I'm wondering why engineers put it on a separate board. I guess the designers are waiting for an integrated chipset. Next are a filter and a filter capacitor. You can find that it is a large film capacitor. What else do we have? There is standby transformer. It's a small transformer for service power and wake-up circuits. There is a service voltage power supply transformer, main transformer for power, and large storage capacitors. What else do we have? Of course, we have a controller, large inductivities as a part of output filter design. There is telemetry and hanger module, board power supply connections, and 2 telemetry connectors. What do we have in the front? Input connector, a telemetry connector for live signal monitoring, left and right outputs with the parallel pins. Great model, really great board. The build quality is outstanding. In some way I'm amazed. Here's a board side view. We can see number of high power components attached to the heatsink. The heatsink in this design is 3 mm thick aluminum plate. Board has 2 options how to connect external heatsink. You can use holes located around the perimeter or secure directly through chassis using threaded standoffs. You need 18 screws for that. It's a reliable solution where heatsink is pressed tightly to the surface. The mounting hole depth is 5 mm. This is how design looks folded. It's time to evaluate assembling. Perfect match. It's easy to mount. The enclosure has been perfectly designed. Chassis cover. You see those small pressed guides. Those guides are going into the matched holes in a chassis. It's a good engineering design reinforcing final assembly and making it lightweight and strong. Alright. So great enclosure. I'm pretty happy about everything. Nice design. Let's start to assemble. I already did the hard part, assembling wire harnessing. In this particular design, I'm using silicone wires. They are very flexible and durable. They can withstand high temperatures as well as low temperature. A board is too good to use low quality assembling components. So I decided to use more than twice higher priced grade silicon insulation wires. Those are 1 mm cross-section tinned strand wires. Here we have a harnessing for service circuits. Great, one more important assembling component for chassis main ground. Balanced and shielded input connectors in case of wake up from signal option. We need one more shielded wire connected to telemetry and service connector. Of course you need a full set of connectors. Those are commodity parts and not worth being listed one by one. You are aware of them. What you need to assemble everything together. You need a minimum of tools. But anyway, you need more tools than typically you have at home. And for me, it's the biggest question either to make a fully assembled kit, because then the price is rising. Or make just a kit and customer will assemble amplifier according to instructions. Good question. High quality fan from proven manufacturer. Arctic Cool is proven German manufacturer. I decided to use in my design only this supplier fans. The fan is critical component because it's mechanical moving part, and I want to match the board lifespan with this component. You also need a PWM controller. I'm using mainstream China manufactured board. It's meant for the personal computer industry. That means they are produced in large volumes. The overall quality and price point is great. It comes as a set including a thermal sensor, all what we need for this project. And you also can program it for different temperatures. By default is set for 35 degrees Celsius threshold or moment when RPMs are going up. For home users, you can raise it up to 50 degrees to keep fan at minimum RPMs and silent operation. Also you need a lot of screws. Input connector. There is nothing fancy. I'm using thin shielded balanced wires for that. When you use 12-volt trigger remote or wake up from signal function, you connect wake up signal to right channel connector pins. Currently I don't have extended controls connector that goes to the board. It's 22-pin connector. In this assembling instruction, connection guides are not included yet. It is kind of final proof of concept, what we are doing right now. There are no secrets in mechanical assembling. I'm showing it in accelerate mode, just to keep a process visible and you can follow if you want. Sometimes when you need it, you can stop the video. There is nothing fancy. You should put screws and washer, spring washer and nut. That's it. Nice and easy. Next step is to connect consumer type connectors. First you should disassemble them and then assemble again through the chassis. Here you are. There are small guides in a connector plastic. Ensure that those fit in a cutout. And then everything will be perfect. When you will cut out using CNC equipment, locations and dimensions are precise. Typically, mistakes are a result from human action. Properly secured connectors will last forever. When assembling, be careful, there are double washers, different type of washers, and you should put them properly, according to the initial state. Once you did washer assembling, secure connector with nut. To secure the nut, you need a wrench. It's much easier to do it with a wrench. Don't have it, use pliers or other tools. This is one more reason for consideration. Should I make this kit fully assembled or not? Assembling takes time, following costs some money. Or I will give it as a kit and you can assemble by themselves. When you are assembling by themselves, you need a little bit more tools. Not everyone has them. And you should visit Home Depot, spend time and money to acquire the full set of necessary tools. Repeating the procedure for the second channel. You can see that kind of easy. Bam, it's ready. Now it's time to secure professional speaker connectors. I have a version with the threads in a plastic. And those are handy to assemble. I like them very much. The key direction should be facing the top. It's important, if you put it vice versa, then your connector pins will not match instruction visual guidance. Your connector keylock will be hard to access as well when it's on opposite side. Then we are coming to the important part, what I mentioned during the designer manual overview. It's about 12-volt trigger, assembling and grounding issues. Ensure that connector has reliable connection to chassis. As next we secure the mains connector. It's recommended to use washer, spring washer and nut. It's critical connector, it's better to secure it properly. The next we mount standby switch. Still thinking, should I use a large but easy to assemble switch or go for small one? Nice looking option. It seems that I'm gonna use a small one to make it more aesthetic. Controller board should be secured by 4, 5 or 6 mm long screws. And now it's time for fan assembling. Measure the wire lengths that should be easy to connect to controller board. Seems like a length is fine. Fan connection should be connected to the controller board first pin. Only controller board first connector has a temperature regulated PWM function. The other two don't. There are 4 screws designed for a plastic. Be careful applying force. Those should be tight but no more. It's plastic. So put a fan and protection grill, a protection cover. Good. Good. My recommendations: use a small screwdriver to tighten the screws. Small handle limits force what you can apply with maximum screwdriver capability. Connect fan connector to PWM controller connector marked with number 1. As I mentioned, only the first pin is working as temperature sensor driven by PWM regulator. Nice. Next, attach the 3mm LED holder. It's a fragile construction, be careful. Don't break small tiny plastic parts, those clips, but otherwise it looks good, and I like the small plastic LED holder. The main switch is rated to the 16 amps. It's an expensive option. Nevertheless, the switch looks like a mainstream piece, don't be misled. Assemble it by applying moderate force and push it in a front panel cutout. My recommendation is to help with a flat screwdriver. You see that my applied force is so significant that it bends front panel material. You will not see in a painted finished version, but anyway. The next step is connect internal components. We are using the same silicone wires. Those can withstand high temperature and they enjoy cable's flexibility. Blade connectors are an excellent choice. This design will be using standardized insulation sleeves, our protective covers for mains, to ensure that the user can't touch mains contacts. This is important component. Mains are directed to safety, and we can't ignore the safety requirements. Start with the main connector and then connect main switch. Contacts connecting in vertical dimension, and we follow with the wire colors. To follow signal path, white to white, red to red, will connect during on-off. Do the visual inspection. Connect blade connectors and put the sealing sleeves on, nice and easy. All those small, tiny components are the biggest challenge for amateur designs. You need a lot of small connectors and a lot of small stuff. Let us tighten the main wires. First put plastic stripes, but don't secure it. Organize and place wires first and then tighten the stripes. The next connector is the ground connector. It is an important connector. It should be properly assembled. Pay attention. A spring washer on a screw. It is must-have spring washer. Secure to pressed threaded standoff. First, just to secure it. Not tighten yet. Connect the midpoint of the mains connector first. Then secure standoff screw. Make sure that it is tight to withstand the worst usage scenario. Think that you have a mobile scenario and traveling around including unpaved roads in countryside. There will be nasty vibrations. Connecting PWM controller board voltage. We need to provide 12 volts to the PWM controller. We don't have 12 volts on ICEpower1200AS2 board, only 15 volts. This is why I'm using LED to drop input voltage. No, for about 1.5 volts. From 15 volts we can get 13.5. Not perfect, but it's fine. PWM board will operate normally. I connect LED directly to 12 volt supply connecting wire. Next we should twist the connection wires for power on signal LED and secure in the LED holder. It's great. Looks great. I'm pretty happy with that. Now it's time to connect speaker connectors. You can see I made them from the silicone wires as well and twisted together. It's important how you position ring to consumer connector. The ring should be placed in a way that you can bend them afterwards. Bend a lot for about 90 degrees. Secure ring with a nut and tighten properly. The connectors must withstand a lot of amps, therefore connection quality is important. Don't forget about the mobile application. Connection point should be ready for vibrations. Be careful, nut should be tight but reasonably tight. I think the connector material is brass or copper. Nuts and threads as well. Those should be tight, but reasonably tight. Now bend them in the optimum angle. The next step is to connect wires to the professional speaker type connector. White is going to connector pin 1. Pins are marked by numbers and polarity. Look at the marks and connect white to 1-. Connect red wire to pin 1+. Read the marks on a connector. That's important. The polarity is critical. Do the visual inspection. Repeat the same activity for the second connector. The same procedure, the same requirements. So, everything is fine. Do the same for professional connectors and do a visual inspection. Don't trust your feelings. Seems all connectors are okay. They're fully assembled. Now it's time to assemble the main board. First you should use a thermal paste a little bit, just a little bit. Apply complete surface. Thermal paste is filling the small scratches and other uneven parts and improve a thermal transmission to the chassis. Secure board with 18 hex screws. It is an easy and simple procedure. The key is to secure the first screw. Don't tighten it yet. With the second screw, go to farthest diagonal. Once you are done, board will be in the right place and the rest of the holes will match precisely. Securing will be a matter of process. Just place the screws, but not tighten them yet. Another tip, do a visual inspection to make sure that there are no wires under the board heatsink surface. Now we are ready to secure all 18 screws. Pay attention to the left side. There are 2 rows of screw holes. start to tighten 2 rows first. Below the surface there are 8 high temperature, high power MOSFETs. And you should provide a good connection with the chassis. These MOSFETs are set for the very high temperature. The temperature protection triggers at 120 degrees Celsius. It's really high. The next step, assemble feet. You need a 8 mm long 3 mm screws with washers to secure feet. Well, washer, 8 mm long 3 mm screw, and foot. Now it's time to connect all connectors. We start with amplifier outputs. Just plug them in a socket according to key direction. The next is a signal connector. Look for a key. The key direction should face the board. Verify, does connector sit deep? Do a visual inspection. Is everything right? One more important point here. You should assemble the input connector according to the designer manual, placing at a distance from amplifier outputs. The input wires and speaker output should be placed in the largest possible distance. I think I made it perfect by the book. You can see that it is a maximum distance for about 5 centimeters. Main voltage connector, just plug it according the key direction. And now we have only a service connector left to be connected. Let's do it. Always do a visual inspection. How does it look? Does everything sit tight? Everything seems fine. Now let's connect service circuits. Put wires in order. It's time to switch an amplifier on. Magic happens. Everything is working. Great. Let's do a final visual inspection looking for the potential short circuits by inspecting potential short circuit places. Everything looks fine. I'm happy with the result. There is nothing that I would like to change. It's time to test a standby function by moving slide switch to standby position. We set amplifier in standby mode and output is muted. You can see that large storage capacitor is still providing energy for service power supply. It takes time to drain energy until PWM fan stops. But it's fine. It's not an obstacle or reason to make changes in design. Let's enable amplifier and you can see everything is on operation mode again. The standby function is necessary to run automation or remote switch it on and off. Now it's time to remember standby power consumption. It's just at 250 milliwatts, almost nothing. One more important consideration. It's about thermal sensor placement. I located thermal sensor close to power supply circuits. Power supply thermal protection triggers at lower temperatures than amplified circuits. It's about 90 degrees. This location will make perfect balance For optimum fun RPMs, the last activity is assembling amplifier cover. See those guides and holes in a chassis. When assembling enclosures, those guides will reinforce assembled unit, making chassis strong despite lightweight and thin material, in our case 1mm aluminium. The final design will be pleasantly lightweight. Then secure the cover with 8 screws, and actually we are done. Imagine chassis painted with nice prints. It will look amazing and professional. I like the final result very much. It's perfect. Depth 200mm, width 320mm, and about 90mm in height. It has been designed for 88mm. All around, great design. It's a great amplifier. During my professional life I built a lot of amplifiers, but this is something. Would I recommend this design for someone looking for one and forever amplifier? Yes, this design is hard to beat. Honestly, I can't find any point to complain. And now it's time to enjoy a piece of music.